Today, we're going to be talking about what are called averages, but there are lots of different sorts of averages. And today we'll be talking about the mean, the median, and the mode. And most of you will be teaching about those at some stage with your learners. And here on the screen, you've got some pictures showing you the sort of thing that we'll be doing. We're going to play a game called the M, and N game. M for mean, M for median, M for mode. And you'll see all the other illustration on this screen. Well, to introduce ourselves, I'm Tony. I founded AIMSEC 20 years ago. I still work more or less full time for AIMSEC, but I'm looking forward to retiring.
Sorry. I can't help it, Tony.
Caroline's laughing because I've often said that and it's not happened, but it's not through lack of my own strong intention. It's just because really we've had some difficulties of keeping AIMSEC on the road because of funding and such like. Okay, Caroline, would you like to introduce yourself?
Hello, everyone. My name is Caroline Ainsley, and I'm the founder of Bubbly Maths. And I'm involved with Tony, the GTEN and AIMSEC because my wish is that every child on earth will love learning and enjoy mathematics. And what better way of making that happen than to work with the teachers to give them all of help get them to work with Tony's wonderful ideas and the work of AIMSEC. Thank you. Temba.
Good afternoon, everybody. My name is Temba Moyo, a mathematics lecturer at AIMSEC. I'm based in Cape Town, South Africa. I'll be a guest speaker together with Tony and Caroline today. Enjoy the workshop.
Okay, now here's the program. This is a little bit more about what we're going to be doing. Now, whenever you see green text, green writing, this is to ask you to do something or to answer a question. You'll have seen this before, I should think. We often use it, well, pretty much every time. And we explain how the workshop, how it works from start to finish in 2 hours. We start off with early years. In other words, young children, before they even go to school, many young children are already learning to count and learning a bit about shapes. And then as year after year, they're on this learning spiral going up and up and up till they leave school as young adults at 18. And they keep revisiting these ideas. We'll show you how they meet the same ideas again and again and again in their school life. And each time they reinforce what they've already learned, which they should remember. If they don't remember it, then then it has to be revised and relearned. But by the time they've revisited it 4 or 5 or 6 or even 12 times in every grade, they should know it well. Okay, so we're going to be working on, we've said this, what are called averages. Now, another word for that is measures of sexual tendency. You may come across that description here. It's usually used in higher mathematics, which you may meet it. And apart from mean, median, and mode, we're going to be considering the range as well. So we're going to start off with finding the median, and that's a simple, very simple activity that you can do with people of all ages. And in fact, this is something you can do with a family, and you could include small children, grandparents, and everybody in between. And you could do it in class or with any group. It's a practical, what we call people maths activity, where you actually get up on your feet and you get involved in the mathematics physically with your own body. And then we're going to look at definitions, formal definitions. and some graphs as well that show mean, median, and mode and different distributions. We're going to think, why should there be different averages? I mean, why have all these different averages? What's the point? Why not just have one and stick to that? And then we're going to play this MMM game. We're going to do a card sorting exercise, which is really good for self-assessment for the learners to relearn something and review it that they have learnt in the past, and for teachers to do some formative assessment. That's the card sorting exercise. We're going to do some problem solving. Our problems are called, two of the problems are richer for poorer and for younger for older. And at this stage, we're getting up into secondary school and even FET work, last 2 or 3 years of school. Match the matches. Well, that's one you could do with any group from about 13, 14 up to school leaving age. And finally, we'll review everything we've met. So, Caroline.
Here's an example of a people maths activity. It's a great way to introduce the idea of averages to an early year. This is the mean we're looking for here.
The median, and Caroline, the median.
I beg your pardon. Oh, I was going to look at them. Sorry, the median. Thank you, Tony. And you've got 6 people. Now the median, as long as they can count, so this can be done as soon as they can count, really. Even so, they still can work out what's in the middle. But if there's no one in the middle, then what do? Well, you go halfway between the two that are in the middle. So that's where the mean comes in. It's the mean of the middle 2 is the median if you have an even number. And you can represent this with this lovely picture, or actually do people maths. And this works with any age to really solidify and help them remember what the median is and how to work it out if there are an even number of people or objects.
Well, odd or even, I would, with the young children, and you know, a class of young children, or a mixed age class where there are young children, they don't even need to be able to count, because they can look at the height. This is for the height. We're looking at the median of the height, and they can arrange themselves in order, talking to the people next to them, swapping places until they've got the orders, maybe with one person standing back to help them do this. And then the person who's sort of directing it can get them to change their line into 2 lines, finding about the middle so that there are the same number of people on either side, so that to stand one behind the other rather than in a line, so they can see, okay, there's the same number of people on this side and there's the same number of people on that side. So they move themselves into 2 parallel lines and then move out again into 1 line. And then it's either one person in the middle, if there's an odd number of people, and that their height is the median, or it's between the two middle ones, as you see between the green one and the sort of turquoise colored person there. So that's how you find the median practically, and you get the idea. It makes a lot of sense without a lot of formula or anything of the sort. So here we're going to move on to the formal definitions. Temba, would you like to talk about these definitions?
Yes, thank you, Tony. Now let's look at the 3 averages and the range, and how do we define these? Let's say you have a set of numbers. We'll use the variable maybe x, say x1, x2, x3 up to x sub n. By mean, we refer to the number of terms in this set divided by, the sum of all the terms in a given set divided by the number of set. You can see the formula on the screen, which is summation of from the first item or from the first data set up to the last one. You add all the terms, then we divide by the number of terms. Then the median, as Caroline mentioned before, you have to arrange these data sets in order of size. Arrange them in order of size, be it ascending order or descending order, and then look for the mean value, which can also be referred to as the 50th percentile. There are times when you find that the number of elements in this particular set is odd. If it's odd, we simply arrange and go to that mean value such that on the left, we have a number which is equal to the number of elements on the right. But there are times when you find that the number of sets is actually an even number. In that particular case, we still have to arrange our number of elements. Then we look for the two mean numbers and then average them. That is, add the two and then divide by 2 to get the median. We go back to that picture which you saw before when Caroline was explaining the median. You can see that the median in this case, with the height of 6 people, it is halfway between the third person and the fourth person. Then we have our third mode, our third average, which we call the mode. This one is simple value which repeats itself more frequently than other values. That is the mode. Then for the range, this is the simplest this is the simplest value of dispersion of elements within a particular given set. That is, it is the difference between the largest element in a data set and the least element in a data set. You simply separate the smallest from the biggest. The value which you get is what we call a range.
And now we have a challenge. We want you to take those 5 numbers, 3, 3, 3, 5, and 6, and work out the mean, median, and mode and range.
We have what we call normal distribution. What do we mean by normal distribution? Graphically, you can see from the graph, we arrange our data set. We show our distribution of the data set elements in such a way that we form a very symmetrical curve, as you can see on the board, on the screen. When the mean, the median, and the mode coincide at the center, such a distribution, we refer to it as a normal distribution. In contrast, you might find that the data elements are shifted. As you can see on my right, the kind of shift which we see here gives us what we call a skewed distribution, where the mean is greater than the median and is greater than the mode, and the median is greater than the mode.
Yes, and there's a very complicated formula for the normal distribution, and a huge amount of work of statistics is based on this normal distribution. So at the moment, we only take a sort of very, very, very simple view of it. But the normal distribution is indeed symmetric, and it's called normal because it occurs very frequently. However, there are other sorts of distributions, and here are 3 of them on the screen now. And in the school leaving years, which would be 12 and 13, learners learn about these other distributions in many different countries. In some countries, they learn about it in university. The important thing is to know under the what conditions each of these distributions are used, and you'll see that the binomial distribution isn't quite symmetrical, but it's it is, and in fact the Poisson distribution, it is actually less skewed, put it that way, less skewed than the chi-squared distribution, and each of them apply for certain types of data. And learning about statistics, you have to learn which of these distributions, and each of them has an equation to you, but you have to, when you're analyzing data and coming up with conclusions about the data, you have to know which of these distributions to use. Now, that isn't for you to teach in school because, well, especially if you're teaching in South Africa, you won't be teaching this in school. It's just for your own information, really. So we come on to just these simple ones that you teach in school. Why different averages? In what situations are they used? I mean, why have different ones? So let's think about that. Now, the arithmetic mean, as it's called, although we often shorten that to mean, the arithmetic mean is better when the data follows a symmetric distribution, like the normal distribution. But when the data are skewed, as you saw on the previous slide, the median's more useful because the outliers distort the mean. Now, what do we mean by that? If we look at the diagram on the last page, you'll see what we mean here. Now, the bigger values on the skewed distribution, the bigger values, of course, they pull the mean in towards the right in this distribution. The higher numbers contribute more towards the mean when you add the numbers up, the data up, and divide by however many there are in the set. And so the mean will not be the typical one, not the typical sort of average. So that is why when the data is skewed, the median's more useful because that is more typical, being right in the center of the distribution. Now, in this table here, look at it. It shows the annual salary of 10 workers. So there is a company that has 10 workers. And if you work out the mean there, this is in thousands. The K stands for thousands of whatever their currency is a year. Then the mean is 30.7. But this isn't typical. Look at the table. So how many people earn more than 20,000? No, only 2 people earn those very high salaries, and most of them earn between 12 and 18K. So the median here is a better average to use. It's the more appropriate for describing the workforce, isn't it? But if the workers are asking for a pay rise, which one would they use? If you were one of those workers, say you're earning 15K, would you use 15.5 as the average if you were asking for a pay rise? I mean, there's lots of strikes going on in our country, isn't there, Caroline? And people going around with banners, protests in the street because they want more pay. And they are very crafty about which statistics to use. And that's why it's important. One of the reasons why it's important to know about, to understand statistics, so you're not hoodwinked by the advertising and the different way people use statistics to make a case or to convince you of something where, you know. So you've got to be able to judge. People really need to be able to judge what is right and what is true for themselves.
It's on television constantly. Politicians, journalists use them to sell newspapers. Oh, 50% in chance of terrible weather or something. They're very selective about what statistics they're quoting. That's even if they understand them fully, and it's up to you to read the small print and figure out actually that's not that significant. Like, oh, 100% more people did this last year than that, but last year it was only one person that did it. So in fact, this year it's only 2 people. It's all very important to know, to understand statistics.
And advertising. Advertisements are the worst, really, aren't they, Caroline? And everybody understands that they have to think a lot. Is what this advertisement's telling me, is it true? Okay, so the mode is of the most interest in a opinion poll, as that's the one that's going to be the most important when you're looking at the voters' first choice. Who's going to win the election? Well, it doesn't matter, the average halfway down the line, who's, what they're going to vote for. Who's going to get the most votes that counts there. Now, shopkeepers use the mode when they decide on which item to stock in greatest quantity. But actually, when they're ordering stock, they prefer to see all the data so they know how much of each type to a thing to, or how much of each size if the item comes in different sizes. Now, there are other averages used in statistics. There's a harmonic mean and a geometric mean and lots of other means. But in lower school and it's certainly in South Africa, you only learn about and you teach about those 3 means: the mean, median, and mode. So now we come to the rules of the game. Themba, would you like to explain the rules of this game?
Right, in the game, we call it an MMM game, that is mean, median, mode game. The teacher thinks of any 5 positive numbers and tells the class their mean, median, and mode. That's the first rule. The second rule, the class are given 2 minutes to find the set of 5 numbers with the given mean, median, and mode. 3, after 2 minutes, players score a point for each solution that they have found. So we can go in and play a game following these rules.
We've already looked at these this data set 33356 and seen that there is one mean. The mean is 4. There's one, the median's 3 and the mode is 3.
And the mode is 3.
So you've already done that, and we had some answers on the chat. But with that same mean, median, and mode, there are lots of other data sets, and that's what the game is about. Okay, it's not really a competitive game, and it's not going to be a competitive game today. We are going to play it. We're going to use several sets of 5 positive numbers, and the first set is the one you see there in red. And I'm going to give you 2 minutes to write down all the different. So we're going to use 4, 3, and 3, and one answer to this game is the data set 33356, and we want you to find as many other sets of 5 numbers as you can in 2 minutes. Okay, starting now, you have 2 minutes to write down all the sets of 5 positive numbers that have the mean of 4, the median of 3, and a mode of 3. 5 positive numbers, and if it's got a mode, then it will have one number repeated at least twice, maybe 3 times. And there are more than 10 solutions. And of course, in the game, the players score a point for each solution that they've found. Now somebody's written down 3, 3, 3, 3, 3. Now that hasn't got a mean of 4. It's got a mean of 3. So it isn't right. And 4, 4, 4, 4, 4 does have a mean of 4, but it doesn't have a median of 3 or a mode of 3. So that isn't right. What do the numbers have to add up to? Think about that. That should help you. If you know the mean, you know what the numbers have to add up to. If you know the mode, you know that there must be 3 repeated twice or 3 times, and perhaps even 4 times. Okay. Right, so we are going to have a look at the solutions. And then we're going to play it with a different mean, median, and mode. Okay. So how many have you got? Anybody got 5 points? Do you know? Here are the solutions. Actually, there's a few more. Now, each of those sets adds up to 20. The numbers add up to 20, so that when you divide by 5, you get the mean of 4. The one in the middle, the third one, is always 3.
Always 3.
And the number 3 comes up twice, or 3 times, or 4 times. It can't come up 5 times because that wouldn't have the right total, and it wouldn't have the right, it would have the mode 3, yeah, but it wouldn't have the right median. So there you have 10 solutions, 11 solutions. I promised you there were more than 10. And there's some more. Now, those we call bimodal because actually 3 is a mode, it's repeated twice, but there's another number repeated twice. So 1, 1, 3, 3, and 12 are a solution, and 1 is a mode as well as 3. 2, 2, 3, 3, and 10 is a solution. Somebody said they got a few bimodals, so discarded them. Yes, well, we're learning how to play this game. We'll allow, I mean, it depends on the rules, and we weren't very clear about bimodal, but we didn't want to overload you. So now you see 2, 3, 3, 6, 6. Only 3 bimodals, but there they are. Every one of those sets adds up to 20. You'll see that 3 is either the only mode or one of the 2 modes, and they all have median 3. So has everybody got the idea now? Now then, I'm going to give you another challenge, another 2 minutes. And here there's a different mean, median, and mode. And now, how many can you write down? Now here, you have a good chance of getting them all because there aren't very many here. Make sure any numbers that you put down have mean 7. And I'll tell you that there are 3 unimodal and 1 bimodal solution. But be careful, you've got to have a median of 6. So 6 has got to sit in the middle. Okay, there they are. Now check yours. Did anybody get all 4 of them right? Now notice they have all got 6 in the middle. They all add up to 35. So when you divide that by 5, you get the mean of 7. And they all have 5 repeated twice. Now, if you look at the answers that are on the screen, you'll find that on the the first one we did on the extreme left, I started with every number beginning with 1, and then I made sure that 3 was in the middle, and there's a particular order there, so that there was a system to make sure that I got every possible solution. And now let's just see. I'm just looking at the comments because I can't find. People say they got some bimodal, and then no, I thought Caroline said that.
Yeah, Pam made a comment earlier. Hold on, I'll find it now. She's
so she said the sum has to be 20, and there should be either three threes with the others adding up to 11. And she didn't quite finish that, but in any case, you've got to have a sum of 20. And if you are careful and systematic about the order, you should get them all. So now if we look at another one, right? We're not going to pursue that. Well, I'm not going to give you the answers for this because there are 45 of them, and we're not going to spend very long on it. So you're not going to find 45, but I'm just going to give you a couple of minutes to see if you can find some answers for this. As Pam said, the median's the one in the middle, so 7 has got to go in the middle here. You've got to have more than one 7, and you should be able to work out what they've got to add up to, what the numbers have got to add up to if the mean is 8. Okay, so there are actually 45 unimodal solutions to this one and 9 bimodal solutions. And if you want all the solutions, go to the Aiming High website, Notes for Teachers, and we're giving you the link there. So what do you think about playing this game? I mean, I'd love to have some comments from you about whether you would have your learners play this game. Well, we think that learners would enjoy it and think of it as a game, not as work, but that they would remember mean, median, and mode, and what they were, and what the difference was, and how you calculate them. Pamela says it's a great arithmetic game, and absolutely so they'll get used to doing calculations in their head, doing them quickly. So it's good for practicing mental arithmetic. Pamela also says finding combinations of numbers that sum to a certain value and still satisfy the other 2 conditions. Yes, and having to check their values as they go along. All good habits to adopt when you're doing mathematics, aren't they? So they get really a lot of practice in many different ways just through this one game.
Imagine the conversations, if you're imagining what this will be like in class, imagine that this is not doesn't have to be a silent game. You can do this in pairs. Imagine the conversations going on between the learners, and they're going to get so solid on their mean, median, mode with playing this game.
Now, you'll appreciate that this is a game also which obviously builds learners' computational skills. It makes them develop those computational skills. You know, when you think of there are 5 numbers, the 7, so I have to multiply 7 by 5. You know, that kind of thinking helps learners develop their computational skills very fast.
Now, there's another comment. It could be quite frustrating for the slower ones. Those the faster ones get excited. So this needs to be managed. The lesson needs to be managed well. Now, with this last one, where there are 54 different solutions, including the bimodal ones, what I would do there is to have the learners work in groups of 4, 5, 6, something like that, and give them a certain amount of time, and not the 2 minutes that we've talked about, but give them a certain amount of time and see which group could find the most in that given time. And I think that would mean that the slower ones would actually be taken up with helping with what the group are doing, and might contribute some ideas, but wouldn't feel, you know, out of it, because there's nothing difficult about any of this. So rather than have a time limit, like 2 minutes for everybody who can individually do the most, as Caroline suggested, you could do it in pairs or teamwork, have them work in groups of 6. And
sorry, go ahead. Sorry, you could also give the slower the ones who work more slowly, not even necessarily the lower attainers, but the ones that work more slowly, give them a challenge, like finding all of the mean, the third column, mean 7, median 6, and mode 5, give let's say the middle set that's going to give them a sense of completion. And if you've got the top high achievers that want to do loads and loads and are going to get it, give them the challenge of finding all of the fourth column. That's an example. You could adjust the challenge according, give each pair a different challenge.
I think one other thing which can work is as you request each learner who gets this set of numbers correctly to explain how they got them. In that process of explanation, surely the low attaining ones will be learning. You know, if you request that you don't just get answers correct, but how did you get this answer correct? That explanation will obviously help a lot in terms of those who are struggling to find the numbers.
And one more, and then we'll move on. In the South African CAPs and in other countries in their syllabuses, they ask for complex procedures. So a proportion, I think it's 20% of the marks on the matric, for example, are supposed to be for complex procedures. What does that mean? It means that it's not just one mathematical idea that you're working on when you solve the problem. You've got to bring in to the mix several different mathematical ideas and combine them. Now, this is a beautiful example of complex procedures, but not difficult. So it's complex doesn't have to mean that the concepts involved are high-level concepts that the learners only learn when they're 16 or 17. Complex procedures apply right down in primary school. It's bringing a lot of different ingredients together and applying them, making up your own recipe, combining those ingredients so that you get an answer to the problem. And here's a lovely example of complex procedures for you.
Right, here you can see we're given cards A1, A2, A3, and so forth. And in each card, find the mean of they are requested. For example, in A1, find the mean of the numbers. What are the numbers? -1, 5, 4, 3, 4, and so forth. Cut out these cards, work out the mean, work out the median, work out the mode, find the range. You know, it is a pretty activity where kids get involved, you know, hands-on on a particular problem. As they cut out and pick out these cards and solve individual problems, that is something which can help our learners acquire skills on, you know, solving these problems on mean, median, mode.
It's also a good conversation generator for working in pairs, so they can discuss which column they should go in, and they've got something physical. They don't have to write it down. They can whatever they're holding physically in their hand, they can put in a place. And then if they think, oh, wait, is that right? They can look at it again and they can keep moving it around until they're satisfied. And a lot of revelations can happen through those conversations.
The minute you finish calculating whatever is required, you'll obviously see from your answers that you need to sort these cards, place the card in the corresponding columns. You can see there are 3 columns there. There's a column headed 3, there's a column headed 3.5, and the other one is headed 5. It will be much easier for you to see where to place the card once you are done with all the problems.
So we have a lot of card sorting activities on AIMSEC, on the Aiming High, and we really believe that they're valuable for learners, and you can make your own. So whatever it is, whatever activity it is, you can make your own. But you'll find a lot on Aiming High. Now, they can do the revision in pairs or groups, and when one learner doesn't remember something, the other learner can help them. When they're sorting cards in this, on one of these types of activities, they can often see from the way it's turning out that one card seems out of place, and they can relearn something together with their fellow students. And it's very good for formative assessment because the teacher can stand back and observe and find out what the learners remember and understand and what they still seem to be not quite sure of. And so we do recommend this type of activity. So we're going to go on now to some problem solving. Madhu moves from Cape Town to Durban, and this caused an average salary to go up in both cities. Now, how can that happen? And how can we explain it? Often in problem solving, we puzzled about a problem. How do we solve this problem? And a good problem solving technique is to try a simpler problem of the same type. Now, instead of 2 cities, and we don't know how many people in the cities, millions actually, we've got 2 small groups. And one group's only got 5 children in it, and another group has got 3. And instead of moving from one city to another, we're going to suggest this simple example that one of the children moves from one group to the other group. Instead of salary, we're going to use the ages of the children. But in other respects, the 2 problems are parallel. And if we can solve the for younger, for older problem, we'll be able to solve the for richer, for poorer problem. That's the idea.
And this is also an activity you can do, as Tony was saying, moving the children in different groups, actually do it, do people maths, actually have people move around, because it's a powerful type of engagement.
So as a preliminary, we've got groups 1 and 2 in this simple case, and we want you to work out the mean of the 2 groups, group 1 and group 2. And if you can suggest solutions to this for younger, for older problem, please do. So we're waiting for some answers on the chat. You need to work out the mean for group 1 and the mean for group 2, arithmetic mean, and some solutions to the question. There's more than one. Some solutions to the question. One child is to leave one group and join another so that the mean age drops in the group left and rises in the group joined.
This is often a very useful strategy when you are given a problem-solving situation where you try to look for a very simpler problem, but which is similar to the complex one. Let learners try to solve this, and using that knowledge, or the solution, they will start thinking of how they can solve the problem, in this case of Mtu's situation. It's a very popular strategy which we encourage all teachers to try and use in the classroom.
Who would leave a group and join the other so that the age drops in the group left and rises in the group joined? I have got one answer now. There are more than one answer. The answers up on the chat is Erin. If Erin leaves group 1 and joins group 2, that solves the problem. But there are other possibilities here.
So if Dudu moved from group 1 to group 2, the average age in group 1 would go down and the average age in group 2 would go up. And if Erin moved, so Erin is 16, it would definitely go down and the average age in group 2 would go up. But if Buli from group 2 to group 1, then the average age in group 1 would go up and the average age in group 2 would go down. It's a really nice, simple problem, and yet it is possible to overthink this, and it again will help learners to get clarity on. And these are very real statistics. These are statistics that are used in real life. That cities and companies and things are constantly looking at things like this.
So here you see there are 3 solutions. I love problems that have lots of solutions because you can then say to the class, who can find another one? So it isn't just the first person to find the first solution that, you know, who's going to get the satisfaction of producing an answer. There's several opportunities there. And the last game we played, the MMM game, we didn't say at the time, but what I love to do there, the one which had 45 solutions, and it also had bimodal solutions, and it also had 45 unimodal solutions and 9 bimodal solutions. That one, what you can do there is you can put the solutions up on a poster on the wall and then just leave it for a few days or a week or 2 weeks and ask the learners, can you find any more? And can you rearrange them into an order that helps you to be systematic to get them all? And that helps learners to think systematically and to plan, you know, to get an answer and work together. And there, because everybody in the class, 54 solutions there would likely give everybody in the class a chance to find solutions.
There's another question, Tony, and that is, what do you need to find? You've got those lists of ages and you've got the question. What do you actually need to calculate? Do you need to calculate the median, the mode, and the range?
No, just the mean.
Yeah, it's just
all about the mean.
Okay. The question you're asking the class is, what do you need to calculate? What's the minimum you need to calculate?
So now let's come on to this question, which is about moving from one city to another and the average salary. So how does this happen? Again, it's like the other problem, the younger older problem. So how does Du's salary affect the Cape Town average when he leaves Cape Town, so that the Cape Town average goes up? So he must earn less than the mean for Cape Town, so that when he leaves, the average goes up. Now that might be quite hard to understand because you're not dealing with actual numbers, you're dealing with the concept, a real deep understanding of what this mean is all about. But if he earns less than the mean for Cape Town and then he leaves it, when you then work out the mean for Cape Town without him, the mean will go up, only a little, but it'll go up. Okay, and then when he goes to Durban, he must earn more than the mean for Durban, so that his salary, when it's taken into account in Durban, pulls the Durban salary, average salary up. And so this will only be possible if the mean salary in Cape Town is higher than the mean salary in Durban. Because in this discussion, in this problem, Dou's salary doesn't actually change. It could be that his company has got departments in both cities and just shifts him sideways without giving him any more money. Okay, so that won't work under other circumstances, but you're actually told in the question, if you look at that link, you're actually told. I deliberately didn't put it in here because I wanted to have that little bit of ambiguity for you to think about. But in the actual question, if I was giving this to the class, I would probably tell them that the mean salary in Cape Town is higher than the mean salary in Durban. That is a fact. Lovely pictures of the two cities there, isn't it, aren't they? Now, something else for you to think about.
So we've got two teams, and we've got statistics to look at. It's a matching exercise, just like we had before. Only you've actually got to analyze what you're looking at. You're not told what you're looking for, but you are given the relative means and relative medians. And so the idea is you've got 6 sets of data. 3 of them refer to Alpha United football team, and 3 of them refer to Beta Rovers. Now, if you work out the mean, median, and mode of each set of data that you're looking at in all those different types of representations, you can match the data to the teams, and we would like you to explain your answers. So if we can have the next screen, unless you've got something else to say, Tony.
I just want to say to everybody, we'll give you a little time to do this and we won't talk, but what you're being introduced to here in this particular session we haven't done earlier is different ways of representing the data. So you have a pie chart at the top, you have a pictogram with footballs on it, you have a frequency chart and a tally chart. Right, now 2 of those charts apply to Alpha United and 2 apply to Beta Rovers. It requires them again to do something that involves complex procedures because they've got to bring a whole lot of different ideas together, all these different charts, try and work out the mean, median, and mode for the tally chart and whether that's Alpha United or Beta Rovers. So for the tally chart, the number of goals is 1 times 3 plus 2 times 2. So that's 3 plus 4 is 7. Plus 3 times 5, 7 plus 15 is 22. Plus 4 times 2, which is 8. 22 plus 8 is 30. So the total number of goals is 30, and there are 15 matches, so that the tally chart has 30 goals in 15 matches. So that means it's 30 divided by 15, the mean is 2. Can you see what the mode is? Can you see what the median is? Median, you've got to be a bit careful about finding the median. I think you find it's 2. So which team is that? Is that Alpha United or Beta Rovers? Here you've got to read the information and match the information to the data that we've now worked out. These averages are in red. The mean number of goals scored by Alpha United is equal to the median, the goals scored, and for Beta Rovers, the mean is equal to the median. The mean number of goals scored by Beta Rovers is equal to the median. And for Alpha United, the mean number of goals is equal to the median number of goals they scored. So it's the same for both. So that doesn't help us. But let's look at the mode. The mode for Alpha United is one more than the mean. Ah, that seems to be in agreement with our tally chart. So did you spot it? That one is Alpha United. Now, which is the chart that gives you the same information as this tally chart? Is it the pie chart? Is it the frequency diagram? Or is it the pictogram? It has no goals 3, 1 goal 3, 2 goals 2, 3 goals happens at 5 matches and 4 goals happens at 2 matches. That is same as the pictogram. So let's look at this one, the frequency chart. If you work that out, it's mean 2, median 2. Same for both of them, isn't it? But here the mode is 1, and that's the clearest indication that they are different, that they've got different modes. And then, so this one is Beta Rovers, this pictogram is Alpha United, and the matches here, the pie chart is Beta Rovers. Now this is super simple. There's only a little bit of data here. And I did with when I was talking a minute or two ago, I did it with the tally chart, worked it out in my head without writing anything down. Now, here in these tables, you will see the method of working out the mean and the angle in the pie chart by setting it out in a table. It could be a spreadsheet, and then you get the spreadsheet to do it for you. And this is how statistics are worked out when you've got a lot of data and you don't, you're not going to do it in, it's not simple like the one we've just done, but this is a simple example. So on the left-hand column is the number of goals, and the frequency is how many matches happened where that was the number of goals scored. And you'll see that the results for Alpha United and the results for Beta Rovers are given there. And in each case, the total number of matches is 15. That's the total of the second column. And then you multiply the number, the data point each time by the frequency, which was the height of the column in the frequency graph. And that gives you, in this case, it's the total number of goals altogether. The total number of goals when there was nothing is when the goals were no goals in a match was 0, and when there were 3 goals in a match and 5 matches, that total was 15, and the total number of goals scored was 30 in each case, and so the mean was 2 in each case. And work out the median, you'll find that you get median is 2 in each case as well. Different modes. I put these tables up because this is when you get much bigger data sets. This is beginning to get the formula that you need, which is each time you multiply x by fx and you get that sum, x times fx, and then you divide by the number of terms in the sequence. Okay, so we've reached the point where we can look back at what we've been doing and review it and think about what we've learned this afternoon, what we've done together. So what we usually ask at this stage is for you to pick out one of these activities and just say something about it, or make any comment you like.
This is really hard to choose from because each and every activity was so valuable in its own way. I love the match the matches because you can apply that to even the local teams that they play themselves, maybe as compared to a school they compete with, and actually put actual values in and compare it and just challenge them with the different charts in that way. But I think my favorite is always the card sorting. It's such a great thing to do as a team, to have great conversations. You get a real buzz with card sorting, but there isn't any one of these activities I wouldn't love to do and wouldn't be beneficial.
Yeah, I always admire the concept of the spiral concept of grading knowledge, you know, starting from the simpler going up. You know, we learn whatever we learn at foundation, it's actually helping us to pick up the next level and so on going up. So that spiral representation of how we acquire knowledge, to me, is something very interesting, you know.
Google Gasa says, I love the MMM game. You have to think more in 2 minutes. Really gets your brain steaming, doesn't it?
I actually like the MMM game, and I particularly like the idea of playing that, you know, once they understand the game, it can be played at the beginning of a lesson and not take very much time. It can take less than 5 minutes in all, because you don't have to explain the rules. But if you as teacher come up with a, you know, a mean, median and mode, and you know what the solutions are, then you can give it to the class, give them 2 minutes, show them the solutions. They can, you know, they can get their scores, and they can actually do it in pairs. And they get a brilliant practice in number work and all the things we talked about. And then I love the sort of activity where there are lots and lots of answers, because that gives everybody in the class a chance to find one. And you can say, you know, at the end of the lesson, don't forget, think about that. Can you bring an answer tomorrow? And it doesn't matter if they get their family involved as well, you know, with this or somebody else to help them. It's going to get them thinking about mathematics and come back and give you another solution. And what's so good about this game is when you have lots of solutions, you've got to be systematic in and get a particular scheme or order so that you can check and it's obvious that you've got them all. And finding that system is the challenge.
So you can do it as a poster and the whole class can agree when you've actually finally. I'm happy with not telling the learners how many they're aiming for, because if they go over, then you can get them to double check and, okay, are they all actually correct?
The matching game was also interesting. If you look at the matching of the pie chart versus the frequency diagram. If you look at the pie chart where there's a 0 goal and you check the other side, 0 frequency, there's only 1 0. Then we have a 2 and a 4 on the frequency graph, which on the pie chart you can see the sector for 2 goals and the sector for 4 goals. roughly you can tell that they are equal. So just following that through common sense reasoning, one can match the two. And to me, that is actually something where if you see a child doing that, you can see that there's some reasoning going on there.
And Vilani says, I like the MMM game. It emphasizes quick problem solving skills. And Pam says, Match the Matches game can inform on the preferred learning skill of a student, visual, spatial, or numerical.
Interesting.
So the matches is a sort of game that, well, puzzle, if you like, activity that you would give the class once. The MM&M game is something that they could do over and over again. You could find different sets of values for the mean, median, and mode and present it as a challenge. And I think, you know, it's something that will continue to give them very good experience and to sharpen them up for the rest of the lesson. It doesn't need to take long, 5 minutes at most. Filani says, I love the Match the Matches game. It's good for problem solving, which we're required to give to learners. An unforeseen problem is a must in our assessment in South Africa. Yes, that's right. As well as what I was talking about, which is a must, that's complex procedures, a problem which is not like anything they've seen before is also the type of thing we want them to do. Well, they need to be able to do, and they need to get plenty of practice in that. Okay, so it's time to say goodbye. It's exactly on the hour and time to end this session. So, well, goodbye, everybody, and we hope to see you next time.
Goodbye. Thank you very much.
Bye.
Got some hands waving there.
Absolutely. Unmute yourselves if you want to say goodbye in person. Bye-bye. It's been a real pleasure. Thank you. This is a Global Teacher Empowerment Network video collaborating with AIMSEC and the Aiming High website. Our mission is to benefit children in disadvantaged communities all over the world by empowering the teachers who teach them mathematics.